So the first question says, determine whether theta equals pi over 4 is a solution of this equation. So let's plug it in. 2 sine. Notice how I'm going to plug in pi over 4 for theta. And we're going to see if this actually works. So 2 sine pi over 4, that would equal root 2 over 2. Minus 1 equals 0. Cancel. Root 2 minus 1 equals 0. That's not true. Therefore, pi over 4 is not a solution. So now we're wondering, what if theta equals pi over 6? So plug it in. 2 sine pi over 6 minus 1 equals 0. Sine pi over 6 is a half. Half times 2, that's 1. And look at that, 0 equals 0, that is true. Therefore, pi over 6 is a solution. So that's our starting point. Now let's see what happens, or how do we do it if we actually have to solve it. So let's try this. What I want you guys to do is draw a box around the sine theta. That's your variable for now. So I know we're solving for theta, but for now, focus on the sine theta. So we have 2 times the box plus root 3 equals 0. Let's solve for the box. I'm going to subtract root 3. So 2 times the box equals negative root 3. Divide by 2. So the box is negative root 3 over 2. Now let's plug it back in. We know the box is actually a function that is sine theta. Once you're here, this is where you want to be. What you do is you think of it as our unit circle. So your work on your homework will look something like this. You think of the circle, and you think, where does sine theta equal negative root 3 over 2? Now you're probably thinking, well, that would be an infinite amount of places because the circle goes forever. That's why we're going to highlight right here. This tells you we're focusing on one rotation only. Okay, so one rotation, meaning theta should be between 0 and 2 pi. So now go back to our circle. Where is it negative root 3 over 2? That's the tick marks in quadrants 3 and 4 right there. So the answer is going to be 4 pi over 3 and 5 pi over 3. And that's it. We just solved our equation. Now let's try our next one. Again, notice that this restriction is there. This will be there for pretty much every problem because it has to tell you what the restriction would be. Otherwise, it'd be an infinite amount of answers. So this is one rotation again. So I'll just note that for you. Notice how it's cosine squared theta. So we're going to solve it by, of course, doing the square root. Now here's the part that's very important to understand. I'll put a note on the side. Note. If you have x squared equals 4, when you solve this, the root of 4 is positive 2. The root of x squared is the absolute value of x. That's very important to understand. I need you guys to write that in your homework, your notes, your tests. I will mark you wrong if you do not show this step, because this is how it actually works. And that means x is plus or minus 2. So again, if you do not write the absolute value, I will mark it wrong. And this will be the root of a half, which is root 2 over 2. And then you get cosine theta equals plus or minus root 2 over 2. And there you go. We just solve it. Think of your circle. That's going to be all the 45-degree answers. So theta is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I know a lot of you are very comfortable with degrees, but notice how radians is actually pretty easy because all the denominators are going to match. So you'll find that radians actually isn't that bad in solving. Now again, I need you guys to really highlight this step. You will need this. And that's because I need you guys to understand that this part over here, this is the part people often get confused, that the root of 4 is only 2. The root of 4 is not plus or minus 2. The root function only generates a positive answer. The root of 4 equals positive 2. So that's why you need the absolute value step, and I'm going to check that as we're working today. Okay, 2 more examples and we're done. Now if you look at this one, notice how it's still our theta to 2 pi, which means we're considering 0 to 360. However, there's something really interesting here. There's a 2 theta. So that actually makes it a little more complicated. What that actually tells you is it's going to speed up the function, meaning the function is going to go faster. So what I want you to do is you think of that as basically saying twice around the circle. So to solve this, what we're going to do is draw 2 circles. 1, 2. We're going to mark everywhere where sine is equal to a half. So just to be clear, in the first rotation we have those 2, and the second rotation we have these 2, which means we have a total of 4 answers. Now here's the important part. What we're going to solve for now is this 2 theta. So we're grabbing 2 theta, and that's going to equal the 4 answers we just found. Okay, so the first one, that would be pi over 6. The next one is 5 pi over 6. Now if you go one more rotation, all we're going to do is add 2 pi. So imagine you just add 2 pi to both of these. The next answer right below it, that's going to be 13 pi over 6. The next one's going to be 17 pi over 6. And again, that's just adding a full rotation. Okay, so I'll get rid of this now. Now you're probably wondering, how can those answers be right? Because we said right here, theta has to be between 0 and 2 pi. And you're right, theta has to be between 0 and 2 pi. That's because look at what we solved for. We solved for 2 theta, which means we're going to take all these answers, multiply it by 1 over 2, and that solves for theta. So the answers are actually pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And notice how all of those answers are between 0 and 2 pi. So I'll box that. There's our answers. Now if you're wondering how these answers work, remember there's a 2 theta in, so when you plug it in, I'll pick one that's weird. Let's say 5 pi over 12. Sine of 2, if you're to plug in 5 pi over 12, that reduces to 5 pi over 6. Oh. And notice how that does equal a half, so that does check out. And that works for all of them. Let's go to the next one. So remember the 2 theta meant twice from the circle? So theta over 2, again, let's highlight this and this. Theta over 2 must mean half the circle. So to start, we're going to draw half a circle. Let's mark where sine hits a half, so that's going to be right here and here. And the process is the exact same thing. We're going to first focus on what's actually in the function. We're going to solve for theta over 2, and that is equal to the 2 answers we just found, which would be pi over 6 and 5 pi over 6. Now we think, is that the answer? No, because we just solved for theta over 2. We have to solve for theta, so to do that, we're going to multiply it by 2, so theta must be pi over 3 and 5 pi over 3. I'm going to box that. Maybe not. And we're done.